Hello students. We'll start with next session. In previous sessions we have seen different types of sorting algorithms, right? What and all the sorting algorithms we have covered till now? Bubble sort, quick sort still we didn't discuss. Selection sort, heap sort, insertion, shell sort, merge, and then radix sort, right? Bubble sort, how it will work? It will bubble up the biggest element or largest element to its appropriate position. So and so on, it will try to find or try to order the elements in left to right order. And selection sort, what it will do, it will select the smallest element in the given array of given elements, and it will place it in the appropriate order. So it will order the elements from right to left. Heap sort, very interesting algorithm. How it will do the sorting? In two patterns, right? We can construct min heap or max heap. If we want to arrange the elements in ascending order, we can construct min heap. Or if you want to arrange the elements in descending order, we can construct max heap. Insertion sort, it is nothing but like inserting a card, right? So playing a cards, how we will insert when we are taking a new card, the same way we are doing the sorting algorithm. Shell sort, that is generalization version of our insertion sort. Here, instead of checking the adjacent elements, first we are dividing the array of elements into some distance apart. So each and every element not going to compare with adjacent element. Instead, it is going to compare with another element which is some distance, specific distance apart. And merge sort, divide and conquer methodology it is using. So first it will divide the elements into, it will do recursively division till the subarray contains one element. Then it will do the sorting. Then it will do the merging. So divide and it will do the conquer. Divide and merge. Radix sort, what it will do? That is based on the place value. This is the only sorting algorithm where we won't use any comparison between elements. So radix are by using least significant digit to most significant digit based on place value. We will put those value in respective buckets so that we have to create all the digits bucket. That means from 0 to 9, totally 10 buckets we have to create, and accordingly we have to sort. And the only sorting algorithm left with, that is quick sort. That is the algorithm we will see now, right? The name itself, what we can understand, quick sort. In module 4, we are having quick sort, right? Name itself, what you can understand, so it will sort a list of data significantly faster. Quickly it will do the sorting. Significantly faster than any other sorting techniques, right? This sorting technique also using divide and conquer methodology only, as what we have done in merge sort. Here also it is dividing array into subarrays, and recursively it will do the sorting. We will see the procedure so that you will understand better. So here the key concept is we have to choose the pivot element. Okay, we have to choose the key element or pivot element. What is pivot element? That is, in each and every iteration we are choosing pivot element. So at the end of the iteration, what should be the result? The elements which are all left side of that pivot element should be lesser than that pivot element. The elements which are all right side of the pivot element should be greater than that pivot element, right? We will see how it is possible. We'll see the procedures first, then we'll move on to examples, right? So usually the first element of the array is treated as key. Okay, so we have to choose pivot element, right? Here key or pivot, any term we can use. Usually the first element of the array is treated as key. but it is not mandatory that you have to choose only the first element. You can choose first element as pivot element, or you can choose last element as pivot, or middle element, or you can choose any random element. All the possibilities are there. You can choose first position or last position or middle position or random element. Accordingly, we have to change the coding. That's it. But the concept is same, right? Concept is what? Once you have chosen the pivot element at the end of the iteration, the numbers which is left side to your pivot element should be lesser. The numbers which are all right side to your pivot element should be greater, right? But usually the first element will be chosen, because why to waste time on choosing pivot element to finding and to finding the mid, right? So simply we'll choose the first element. And here we have to use two pointers, left pointer and right pointers, right? Here we are using two pointers, left and right. So what is the purpose of left and right? Okay, so once we have chosen the pivot element, okay, the first element we are choosing is a pivot element. So the second element we are considering as a left. Okay, that left pointer pointing the second element index, and last element index will be pointed by right pointer. Okay, so three variables here we have seen: pivot, left and right. Pivot is nothing but we are choosing any one key element. Usually the first element can be our pivot element. What is the second point? We have to assign left and right pointer. What is left? That is, we can start pointing the second element. And what is right? It will start pointing the last element. That is index. It will point that index, right? And what we have to do, how we have to proceed. So the index variable left is incremented by 1 till the value stored at the position left is greater than key. That is, so what is the left pointer? Initially we are pointing the second element, since first element is pivot element. So we are checking the condition. What we are checking the condition? From the left index position, we are taking that element and comparing against pivot element or key element. We can increment by 1. How long? Till the value stored at that position left is greater than that key. Okay, the number which is pointed by your left pointer, if it is okay, the number which is pointed by left key, okay, that should be lesser than your pivot element. If it is there, okay, fine, you can increment, right? And else you have to stop till that. If it is greater, you have to stop. That is the point here. The same way, you can increment the right pointer, okay, when the value pointed by the right index, if it is greater than the pivot element, yes, you can increment. But till when? Till if the value stored at the position of right is smaller than key. So you should not move in that place, you have to stop, right? Okay. Now, I stopped the left index by checking one by one, and I stopped the right index by checking one by one. At some condition, it will go wrong. Now, after both pointers, left and right, got stopped moving, I can exchange both values which is pointed by left and right respectively. Okay, and again from the current position, that is where we stopped left and right, again we can do the procedures. Again, left and right pointers can be incremented and decremented respectively based on the lesser greater concept. And when it both pointers movement is stopped, we have to exchange both left and pointer values. Till when we have to continue this? Till when both left and right pointers are crossing each other. When, so we have to continue the procedure, but we have to stop at one end, right? When means when both left and right pointer crossing each other. That means we came to an end of one iteration, right? If that happened, if those variables left and right crossed each other, That time what we have to do, this is very important point, that time what you have to do, you have to exchange the pivot element or key element with the right index value, right position, right index value, the right pointer, which value it is pointing, that value will be swapped with pivot element, right? It means whatever we have chosen pivot, in that iteration we came to end, that is the numbers which are left to your pivot definitely will be less than that your pivot, and numbers which are right side of your pivot element should be greater than that, right? And now we got the two subparts, left side subpart, right side subpart, and in middle our pivot element, because at this stage our pivot element will be in perfect position, it will sit in its appropriate position. Okay, we will see with an example, don't worry. Now whole array is divided into two parts, left and right part, right? One part containing the elements less than the key element, the other part is containing greater than the key element, that's all. So it means what, our position of the pivot element or key is fixed now, right? The same procedure will be followed for right subarray and left subarray, right? After some iteration, we will end up with subarrays containing single element. If there are single element, we don't want to do the procedure because no more elements to split, right? That time, definitely the array will be sorted. So we will see with one example. Better we will do instead of okay. Some examples we will take. We itself will do that. Some elements we will take, for example, 54. We'll make it into big size. 54, 26, 93, 17, 77, 31, 44. Some examples, 55, 20, 54, 26, 93, 17, 77, 31, 44, 55, 20. So totally how many elements we have? 3, 6, 9 elements we took. It's enough. Then it will take too much time. So 9 elements we took. What is the first step? What is the first step? We have to choose our pivot element, right? We have to choose our pivot element. So usually we will choose the first element as a pivot element, right? Usually we'll choose first element as a pivot element. Now, what is a pivot element? Now 54 is our pivot element now, since usually the first element can be pivot element, right? Okay. What is our next step? We have to, the next step we have to point left and right point. For simplification, instead of pivot, I will write P. Now we have to point our left and right, choose left and right pointer. What is the left pointer? The second element. Second element will be pointed by left pointer, and last element will be pointed by our right pointer. This is the first step. What is the first step? You have to choose the pivot element. Usually first element can be our pivot element. Okay. And what is the next step? The second element will be pointed by left pointer, and the last element will be pointed by the right pointer. This is the preliminary steps we have done. So next step, what we have to do, we can start the comparison, right? So what is the comparison? I have to check. I have to start with left pointer. First, I have to start with left pointer. What is the left pointer? I will write here. What is the left pointer? 26. So whether 26 is less than 54. So we have to check for lesser condition, right? Because left side element should be lesser than our pivot element, right? So that is why we're checking for left lesser condition. Whether 26 less than 54, yes, it is true. So if it is true, what we have to do? If it is true, I can move my left pointer, right? If it is true, I can move my left pointer. So from 26, I can move my left pointer to 93, right? And again, I'm checking with 93. How I can check with 93? Whether 93 less than 54. I'm checking whether 93 less than 54. Whether 93 less than 54? No. So I cannot move my left pointer. So here I am stopping moving my left pointer. What we have done, pivot element we have chosen, left pointer, the second element will be the left pointer, last element will be pointed by right pointer. After that we can start checking against with pivot. We can start from left pointer was pointed by 26, whether 26 less than 54 we are checking, because against pivot element we are checking. Since left pointer is checking against less than condition, because left side element should be lesser than pivot element. Whether 26 less than 54, yes. If it is true, I can increment by 1. If it is not, I cannot increment. So now I am again checking whether 93 less than 54, no. So the condition gone false, so I cannot do the increment. So I just stopped. Now I can go for right pointer. I can check the condition. What is the condition I should check? With greater, right? With greater than condition, that is whether 20 greater than my pivot element. Whether 20 greater than my pivot element? No. So I cannot increment, I cannot decrement my right pointer towards left, right? So here also I'm stopping. So I started checking left pointer. It is less than, so I incremented 1. It is not less than, I stopped moving. After left pointer gone false, I again started with right pointer. Right pointer, what I have done, I'm checking the first condition itself false, so I'm not moving. So at this step both stopped moving. What we have to do, we have to exchange both left and right pointers value, both left and right pointers value, which is pointed by left and right pointer. What are the values? 93 and 20. So at this step what we have to do, swap 93 and 20. So what is the resultant array? 54, 26. It will be swapped, right? So instead of 93, 20, because we have to swap, rest all will be same. 20, 17, 77, 31, 44, 55. Instead of 20, we have to put 93, because these two elements swap together. Now, as usual, pivot element won't change. This is my pivot element, and this is my pivot element. Where my left pointer start, because from that position only we have to start. 0, 1, 2. Second index it had stopped. So my left pointer is here, and where my right pointer stopped, because it doesn't move at all. Again we have to start the same procedure, because still when we have to do the same procedure, still both left and right pointer crosses each other. So again we'll start same procedure. Right? So I'm just checking with whether 20 less than 54. Yes. Okay. So I will write the condition over here. 20 less than 54. Whether it is true? Yes, true. If it is true, what we have to do? We have to move one step ahead. So we can move one step ahead. Again, what is the step 17? Again, we can check. What we can check, whether 17 less than 54 or not. 17 less than 54. Whether 17 less than 54. Yes, it is true. Again, what we can do? We can increment left pointer by 1. And what is the next element? Next element is 77. Again, we have to check whether 77 less than our pivot element, nothing but 54. Whether it is true, we are checking. No, it is wrong. It means I cannot move the left pointer further. I have to stop here. Now, once the left pointer stopped moving, I can start with the right pointer. We will start checking. What is the right pointer value? 93. So I can check whether 93. Here we have to check with greater than our pivot element. Whether it is true? Yes, it is true. So what I can do? I can decrement one position, right? So it can start moving. So it will come here. What is the next element? Again, 55. What is the condition? I have to check whether 55 greater than 54. Whether it is true? Yes, it is true. If it is true, what we can do? Again, we can move our right pointer. So again, what is, I have to check with 44. That is 44 greater than 54 or not. Whether it is true? No, it is wrong. So I cannot move now. Correct. So both in this stage, both left and right pointer stopped moving. So when both start moving, what we have to do? We have to exchange both values which are all pointed by left and right pointer respectively. Correct. So we have to swap 77, and at this stage what we have to do? We have to swap 77 and 44. Right. So we will write the resultant array. (54), it won't change our pivot element. 26, 20, 17. 77 will be replaced by 44. 31 will remain same. Instead of 44, 77 will come. Both 55, 93 remain same. Right? So what is our next? Yes, this is our pivot element. Pivot element, and same, the left and right index won't change, same index. Okay, so we have to start from this index only. Again we will start. So what is the condition? Again we can check the condition. Start with left pointer, whether 44 less than condition, we have to check less than pivot element or not. Yes, it is true. If it is true, what we have to do? We can increment the left pointer, right? So you can increment the left pointer by 1. Again, what is the condition? We have to check with the next element. That is whether 31 less than 54. Whether it is true? Yes, it is true. So what we can do? Again, we can increment the left pointer. I'm just incrementing the left pointer. So my left pointer pointing here. So I'm just moving here. So now both pointing the like this. Okay. Now again we are checking, because still left pointer didn't stop moving. Again we are checking whether 77 less than 54 or not. Whether 77 less than 54. Whether 77 less than 54? No. So left pointer stopped moving. If left pointer stopped moving, we can start checking with right pointer. Right. So what is the right pointer? 77. So we are checking whether if it is right pointer, we have to check with greater than. Whether 77 greater than 54? Yes. If it is true, what we can do? We can decrement right pointer by 1, right? So excuse, excuse. So my ref pointer pointed by 31. Now again I can cross check whether 31 greater than 54. Since it is right pointer, I have to check with greater than. It is not true. So, and also I'm checking. So it stopped moving. Both left and right pointers stopped moving. Also, we should see that, we should observe that both left and right pointer crossed each other, right? When both left and right pointer crossed each other, what we have to do at that place, we have to swap pivot element with right value. So, and this place, what I have to swap pivot element and the element which is pointed by right, that is 31. Because at this stage both right and left pointer crossed each other. So since it crossed each other, what we have to do, we have to exchange pivot element and right element. Okay, so the resultant array, pivot, instead of pivot element, the right element will come. What is the right element? 31 and 26, 20, 17, 44. 31 will be replaced with 54 because we are exchanging both value pointed by right pointer and value pointed by pivot, right? So what is the pivot element we have chosen here initially? 54. Where is our pivot element? 54. We will just check whether the values which are left side to my pivot element, whether it is lesser or greater. Lesser, right? All the elements which are all left side to my pivot element is lesser than my pivot element, and the values which are all right side, all are greater than. So these left side elements are lesser than my pivot element and right side elements are greater than my pivot element. Yes, so it means we came to an end of the first iteration, that is the our pivot element position is fixed. Correct, it is exact position in sorting order. So this position is fixed. So now this is left subarray and this is right subarray. So we have to do the same procedure with left subarray and right subarray. So just for example, I will explain only left subarray. What is the left subarray? 31, 26, 20, 17, 44. Same procedure, right? Since pivot is fixed, so the left side should be sorted separately and the right side should be sorted separately. Okay, now as usual, imagine this is our new array, right? What is the first step? We have to choose the pivot element. Usually the first element will be our pivot element. So what is the first element? 31. 31 will be our pivot element now, right? Okay, what is the next step? We have to choose, we have to place our left pointer, that is which is next to the pivot element, that is second position, and the right point, right? Right pointer, that is This is left pointer. This is right pointer. We will start doing the procedures. So we'll start checking. What is the first step? We have to start with left pointer. Whether 26 less than 31. Yes, that is true, right? So what I can do, I can increment my left pointer to one position. Again, I'm checking whether 20 less than 31. Yes. So again, I can move my left pointer. And again, I'm checking whether 17 less than 31. Yes, true. So what I can do, again, I can move my left pointer. And I'm checking whether 44 less than 31. No. So here I'm stopping my left pointer movement. Later, I can start with right pointer. Correct? Okay. What is the condition? We have to check for greater. Whether 44 greater than 31. Yes. So I can decrement one position. Whether 17 greater than 31. No. Okay, so both left and right pointer stopped moving. That time we have to check whether both left and right pointer crossed each other or not. Here both left and right pointer crossed each other. So what we have to do? That time we have to swap right and pivot element. What is the right element? 17, and what is the pivot element? 31. So what is the resultant array? What is the resultant array? 17, 26, 20. Instead of 17, I have to put 31 and 44, right? 31 and 17, right and pivot element will be exchanged. 31 and 17. Now as usual, we'll start. We know that this is our pivot element, and right element will be pointed by fourth position. So right element pointing here, and left element is pointing to the last element, that is pointing here. No, I'm sorry. Since it's crossed each other, so we have to swap right and pivot element. So we swap right and pivot element. So it means when it's crossed each other, it means we came to end of that iteration. That is, our pivot element might have found its appropriate position. We will check where is our pivot element. This is our pivot element. So we'll check whether the values left side of my pivot element, whether it is less than or not. Yes, it is less than my pivot element. The values which are left to my pivot element, whether it is greater than or not. Yes, it is greater. So it means my pivot element found its appropriate position. And again, what we have to do, left side and right side, we have to do separately. Yes. Now if we take 17, 26, 20. See, 17, 26, 20. What will happen? 17 will be our pivot element, because first element we have to choose as a pivot element. 17 will be a pivot element, and what is where our left will point? The first element next to pivot element, right? So left pointer will be pointed here, and right pointer will point the last index. What is the last index here? That is 20. Okay, now we can start checking. First we'll start with left pointer. Whether 26 less than 17? No. Here itself our left pointer stopped moving. We'll come to right pointer. Whether 20 greater than 17? Yes. So I'm decrementing one place. Whether 26 greater than 17? Yes. Again I'm decrementing one place. Also, I'm checking, I am observing both right and left pointer or crossed each other. That time what we have to do, that time we can start working and we have to exchange pivot and right element. Since pivot and right element pointing the same element, it means no need of exchanging. 17 is already there in the perfect position, right? What we have to do, our pivot element found its position, so no left side elements, and all the right side elements are greater than 17. And again we have to start the same procedure with the remaining elements 26 and 20. So what is our pivot element? As usual, first element. And what is our left element? It will point the second, that is next to pivot element. What is our right element? It will point the last index. Since only one element, it will point here. Now we will start with left. What will happen? Whether 20 less than 26? Yes. So what we'll do? We will increment my left. Correct. And whether 20 greater than 26? No. So here it is stopped moving. Correct. So that time we are checking both left and right pointer are crossed each other. When both are crossed each other, what we have to do? We have to replace 20 and 26. Correct. So what is the resultant array? What is the resultant array? We have to replace 26 and 20 because right and pivot. So 20, 26. Okay, we'll just check recursively. So from this elements we have called this. So what happened? 17, 20, 26. Right. And we'll come back here. From this we have got this separate array, these sub-array that is already sorted, that is 17, 20, 26, 31. Since only element is there, it won't get, I will write. We'll start with, okay. We have started here, and we are separating. So only I have done the left part, only I have done the left subarray. 5 elements have gone for left subarray. In that again I have got 2 subarray. Again I have done that sorting resultant. So this result is 2026. I am putting here. So 17, 20, 26, 17, 20, 26, 31. Since it is, we can call recursively, it will go to the previous step, right? And already 54 we have done the sorting. See, already 54 we have done till this it is sorted. So again we have to do the same procedure for right side elements also. That's all, right? So you have to work by your own by taking as new elements with set of maybe as initial step you can start with 5 or 6 elements. The same procedure you try to do, you will get better understanding. Thank you guys. Next session we will see some other topic. Thank you.